Okay, the third trig lesson. This is going to tie in some of the stuff from the first two, and it's going to start prepping for the fourth one, which is when we actually start tying everything, all the concepts together. Now, what you should have learned from the last thing, I'm going to put an example up in a moment. Poof, there's your question. Suppose I told you that the sine of angle theta is negative 2/3, and that tangent greater than 0. What the hell is that supposed to be? What quadrant is theta in? Well, first I need to figure out what the hell this is. I've never seen this. What is this supposed to mean? Let's see. If a number is greater than 0, what's a number greater than 0? 1, 5, 100, 1,000,000. All the numbers greater than 0, I'm pretty sure those numbers are positive, right? Okay. So, the question is, where could this angle possibly be? Now, I had you draw reference angles in lesson 2. Reference triangles in lesson 2. I had you plot a point and draw a reference triangle, and then figure out the values of sine, cosine, and tangent, and so forth. And the reason that I had you do that was that depending on the quadrant you land in, some of these guys are positive and some of them are negative. Now, what you should have discovered from what you were doing was that when you were in quadrant 2, sine was positive here. And sine was positive here, right? Everybody's positive in quad 1. Remember quad 1, quad 2, quad 3, quad 4. Now, I gave you a negative here. So you're definitely not there, and you're definitely not there. Now, I'm also telling you tangent is positive. But if you drew your triangles and you filled in the sides and the values, you discovered that over here, tangent is negative. But I'm just telling you tangent is greater than 0, which is positive. So you're not here. So you must be in quad 3. It's confusing. I don't understand what the hell you just did. You have to say that again. And I don't, because I'm going to show you a really fast, easy way to determine what quadrant you're in based on your signs. There's a nice little acronym. So the important thing, this lesson, by the way, this is what I hate doing, is that this lesson, most of the early trig lessons work very poorly unless I have people in front of me to stop and continually ask questions about. So it's, I apologize if it's weird and watching all this, but these lessons seem disjointed because they're supposed to be done with you guys in front of me so I can constantly stop and have you do stuff. Really, I do these first 3 lessons in usually 1 or 2 classes. Most of the time 2 classes. It's hard to do in 1 class, but it goes very quick once I show all this. Each trig function, right? You have sine, cosine, tangent, and then you have the partners, cusc, sec, and cot, right? Cosecant, secant, cotangent. Each one of them is positive or negative, depending only on the quadrant that it lands in. Now, in the first quadrant, all 6 of them are positive. No one is negative in quad 1. Now, when you're in quad 2, only sine is positive. Cosine, negative. Tangent, negative. When you're in quad 3, tangent is positive. Sine, negative. Cosine, negative. When you're in quad 4, cosine is positive. Sine is negative here. Tangent is negative here. In quad 4, tangent is negative, just like I showed you in the previous example. So you see A, S, T, C. What does that stand for? All stewardesses travel continuously. That's not what it stands for. All students take calculus. That's not true, though. All students don't take calculus. All scientists take calculus. I wasn't going to say anything else. Right? All scientists take calculus. Calculus, yes, they do. So the letter tells you who is positive in that quadrant. In quad 2, only sine and his partner are positive. If this dude is positive and you flip him over, if I have the number 2/3 and I flip that over, it's still positive. Tangent is the only one that's positive in quad 3, and cosine is the only one that's positive in quad 4. We are going to tie all this. Is very important to know this. We're going to do this in lesson 4. You'll see how it ties into what I'm about to show you now. Okay? All right. This concept is going to seem very strange at first if you've never done it before. What we're going to talk about are called reference angles. Again, all the things I'm doing right now are going to tie into lesson 4. You are not going to understand a damn thing I do in that lesson unless you really understood what I did in lessons 2 and 3. Okay, so in lesson 2, you were drawing reference triangles, and I told you that inside of the reference triangle lived a reference angle, and I also told you it would be important later. I'm going to give you an angle in a minute. What you're going to try to do is you're going to try to draw this angle. And why do you try to draw it? Well, you try to draw it because you got to figure out where it lands. Why do I need to know where it lands? Because the thing being positive or negative depends on where you land. For instance, if you land in quadrant 2, tangent is negative there. And I need to know this kind of thing. So I'm going to do an example real quick. Poof. So there is a problem. Find a reference angle in quadrant from 145. Now, I haven't even really given you a whole lot of detail of what the hell this reference angle is supposed to be. Now look, I'm going to draw myself a little grid here. I know that that's 0. I know that's 90. I know that's 180. Whoops. And I know that's 270. And I know I come back around to 360, right? Right? Each quadrant is 90. All the way around. Go all the way around the circle. Now, 145 is here. Now look, am I going to draw this perfect? No, I'm not going to draw this perfect. I know that I need to start here. This is a positive angle, so I'm going to go up and around. Right? So I'm going to start drawing it. That's 90. Now, I have to go a little bit further. I don't know. It's maybe around there. Okay? This is my angle. I mean, I drew it horrible. There it is. That's my angle, right? I started here and I went, my hand don't bend that far. So that is roughly 145, okay? I don't expect you, that's why I put draw in quotes. I don't expect accuracy here. I expect you to just be able to tell me what quadrant it lands in. Now, your reference triangle used to be over here, right? This would be your triangle. Remember how you drew it in lesson 2. You connect the thing to the origin. You drop the other side to the x-axis. And then you put the little angle here. Now, why am I doing this? This is your reference angle. Right here. That's the reference angle. So your job, this whole thing was 145. Your job is to figure out how much this angle is. What's this arc right there? So this is why I'm doing this example to illustrate. I hope that you can tell. In order to figure out how much this little piece is, I hope you can figure out that you have to take 180 and subtract 145. So I'm going to do that. So let's see. I reverse add. I never subtract. I add 5 to this, I get 150. And then I have to add 30 more to get to 180. So this is 35 degrees. 35 degrees where? In quad 2. Now, this is very important, so please listen carefully to what I am about to say. I am not suggesting to you that 35 degrees and 145 degrees are the same angle. They are not. But I am telling you that to reference this angle, 145 degrees is equivalent to having 35 degrees in the second quadrant. At some point, you're going to be finding values of these. Like I'm going to ask you what the sine of 145 degrees is. I need a reference to this. I don't know what the hell 145 is. So what I do is I find a reference using a smaller angle that's in a different quadrant. So 145, so don't worry about this for now. That's later. 145 is equivalent to 35 in the second quadrant. And I'm going to do a couple more after I give you the formal definition of reference angle. Okay, so I'm writing the official definition. A reference angle is an acute angle, a cute little angle, tiny. It is an angle between 0 and 190. Between 0 and, I'm sorry if I said 190, 90. Between 0 and 90. You cannot be 0, okay? And you cannot be 90. You have to be between. So you can be 1, you can be 89, but you can't be 90, okay? So it's an angle between 0 and 90 degrees that is equivalent to the angle theta that you start with. So I start you with an angle. Like let's say I tell you that your angle is 200 degrees. And I want you to find the reference angle and the quad how on earth do you start this? Well, you start it like I told you before. 0, 90, 180, 270. You're going to draw. Now, I know that all the way to here is 180. And I have to go a little bit more. Why are you drawing that there? This is a reference triangle, right? The reference angle lives inside the reference triangle. You see, the problem is, and I've done this a lot of years, students want to put the reference angle right there. And it doesn't go there. Your reference triangle doesn't go this direction, right? That's not your reference triangle. I had you in lesson 2 draw a reference triangle in each quadrant. In quadrant 2, 3, and 4. So you saw what they looked like. Your reference triangle in quadrant 3 looked like this, right? It's upside down, but the reference angle was right there. So I know that this angle is 200. You see it? You see this piece? There you go. You have to find that piece. Now listen, don't freak out. This is really confusing. When I'm done with the examples, I'm going to write for you formulas to use depending on the quadrant that you land in. There's a formula to figure out the reference angle when you land in quad 2, 3, and 4. And I'm going to write them, I promise. But for now, I just want you to follow and understand. I drew 200 degrees and I landed in quad 3. Okay? 1, 2, 3, 4. That's quad 3. I need to know what this little piece is. Well, I mean, come on. I start with 200 and I take away 180. And I get 20 degrees in quadrant 3. Now remember, I am not suggesting to you that 200 degrees and 20 degrees are the same angle. They are not. But if I draw a 20-degree angle in quadrant 3, that is equivalent to me drawing a 200-degree angle, starting from where I always start from. So if I just went to quad 3 and drew a 20-degree angle, that's the same as drawing a 200-degree angle. They are equivalent, okay? That's what it means. Just like 1 over 2 and 3 over 6 are equivalent to each other, even though they look different. 20 degrees in quadrant 3 is 200 degrees, okay? They're equivalent to each other. I'm going to do one more, then I'm going to write for you all of the little rules. Okay, so by process of elimination, since I already did one reference angle that lands in quad 2 and another one that lands in quad 3, I'll give you 3 guesses where this one's going to land. The first 2 guesses don't count. 0, 90, 180, 270, and back around to 360. I mean, you have to put it there. I mean, if you go all the way around, you come to 360. So now this angle is 310. So it's going to go 90, 180, 270, and maybe it's about there. Maybe I went too far. I think I went too far. Whatever. Now, where would your reference triangle go? Would you draw your reference triangle this way? Or would you draw your reference triangle this way? Remember, the reference angle lives inside the reference triangle. This is your reference angle right there. Not here. You will get a different answer if you don't put it in the right place. This is critical. This is why I do the other lesson first, where I have you draw the reference triangles. Because if you don't draw the reference triangle right, if you draw it toward the y-axis, you're going to put this angle here, and then you're going to end up using the wrong thing. Now, this was 310. Now again, can you not see all the way around to here was 310? If I kept going a little bit more, I'd hit 360. So I mean, come on, using the smallest amount of brain power possible, what could you possibly do with these numbers to figure out the size of this piece? I mean, give me a break. This is always going to be the game. You're always going to be subtracting. Also, I'll write the correct number down, right? 50. So you would do 360, take away 310, and you would get 50 degrees. 50 degrees where? In quadrant 4. Again, this is critical. 50 degrees in quadrant 4 is equivalent to you drawing 310. This is the reference angle for 310 degrees. It would be 50 degrees in quadrant 4. Okay, so now as I promised you, I will write you a list of formulas. First, I'm going to draw you what the reference angle looks like in each quad, and then I'm going to draw you the formula. Now, be very, very, very glad you didn't have to watch me draw all this crap, because it took me like 5 minutes. So anyway, this is how you find... First, I want to point out a couple things. Quad 1, if your angle lands in quad 1, it is already between 0 and 90, correct? So there is no reference angle. Like if I told you 40 degrees in quad 1, what's the reference angle? 40 degrees in quad 1, duh. It's already between 0 and 90. So we're only talking about quad 2, 3, and 4. Thank God there's only 4 quads altogether. So here's what your reference angle looks like. If your angle is between 90 and 180, you landed in quad 2. If your angle was between 180 and 270, you landed in quad 3. And if your angle was between 270 and 360, you landed in quad 4. Now, here's where your reference angles would live. In quadrant 2, right? Remember the reference triangles. Boop, boop, boop. Boom, 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 boom. Boom, 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 boom. Right? Those are your reference triangles. So the reference angle here, right? Inside the reference triangle. Here, here. Now I'm going to write the formulas, and I'm going to show you why. If you draw your reference triangles wrong, you're going to have the wrong thing. Okay, poof, I wrote the formulas. So look, you start with an angle, right? Like let's say I start you off with 150 degrees. 150 degrees is between 90 and 180, right? So you would take 180 and subtract. See, here was your angle. This was your angle. You're going to do 180 and take away that. So if your angle had been 150, you would do 180, take away 150, and get 30 degrees. Okay, so this is the angle that you start with. If that angle lands in quad 2, whatever it is, 170, I think I did 145. So I did 180, take away 145, because it landed in quad 2. Okay, so this is how you get the reference angle if you land in quad 2. You take 180 minus the angle you started with. Okay, that's your starting angle. Just so we're really clear on this. Now, when the angle is between 180 and 270, let's say it's I think I did 200. It could be 240. It could be, 225. Whatever. If it's between 180 and 270, you take the angle you start with. Like I gave you 200, right? And you subtract 180 from that. So whatever it is, as long as it's between 180 and 270. Now, if you drew this reference triangle here, you would not use 180, you'd use 270, and you'd get it wrong. What would 270 take away 200 be? It would be 70. If you have to use 180, like the example I did, that's what I got, right? I did 200, take away 180, and I got 20. If you use 270, you don't get the right thing. 270 take away 200 is not 20. The reference angle is 20 for 200 degrees. So you have to make sure 180 take away the starting angle take away 180. So look, you're using 180 twice. You're using it in quad 2 and you're using it in quad 3. It's just reversed. You see how it flips? Now, in quadrant 4, this is who you're using. Whatever the angle was, again, I think what I have, 310. So I did 360, take away 310, and I got 50 degrees. So you take 360 and you subtract whatever angle I gave you in the beginning. So if I had given you an angle of 300, you do 360, take away 300, you get 60. Okay? So this is how you find the reference in each of the quadrants. You use these formulas. Okay? If you want to replace these things with thetas, I don't want to put theta there because I put theta here, but whatever. You could call that theta if you want. So, but these are your starting angles, whatever angle I gave you in the beginning. All right? So those are the formulas. Now I'm going to show you in a second what the heck you're doing this for. Now, this will be the beginning of the next lesson, but I just want to tell you really quick. In lesson 1, I gave you stuff like this. And I told you sine is opposite over hypotenuse, right? Smelly old hobo. I had you draw a triangle. I had you put the opposite and the hypotenuse sides there, find the missing side, and then read off what cosine is and what tangent is and so forth, okay? But here, you didn't know what this angle was. Now, you're going to do a different thing. I'm going to give you this angle, theta, like I'm going to say it's 220 degrees. This time, you got to tell me what the number is. See, I never told you the angle. I just told you the value. Every time there's an angle, though, you get a value. So in the future, in the next lesson, I'm going to be giving you angles. You have to tell me the number that you get, the value that you get. Now, remember, the quadrant tells you whether the value is positive or negative, so it matters very much where this angle lands. And it also matters very much what angle is equivalent to this angle. So you're going to have to figure out a reference angle to this dude, and you're going to have to figure out where he lives to know whether this would be positive or negative. And it gets pretty involved. That's why I had to do all of this preliminary stuff before we get there. But here's where we're going to go in the next lesson to give you a little preview.